So we're identifying jewelry interns fraudsters with AI. I'm Xander Russell.
I'm Amanda Listwood.
I'm Trevin Salvo.
I'm Lana.
I'm Hanchi.
And so I'll first do a quick project overview. Our client is Jewelers Mutual Group, and they tasked us with a binary classification problem, looking into jewelry insurance policies. And we'll also be assessing risk of those uh, through feature engineering and creating custom flags. And then eventually, we developed a model that takes all of that into account with new incoming policies.
So we first learned different modeling techniques with different packages and then experimented with mainstream models that come in already template forms. Then we found that they were kind of insufficient to fulfill our purpose. And so we did more EDA and feature engineering to kind of isolate the key flags. And then finally, we built a final model with ensemble methods to combine the strengths of each model. With the data we're given, we have 1.2 million rows of policies along with their early loss 90 days labels. And then we also have around 1,600 of for motive data. But due to how little for motive data intersects with our 1.2 million rows, which is around only 900 and just not enough early loss cases to consider, we decided to do that in another time and focus on the 1.2 million rows first.
So here's some of the models that we tested, just like the basic cat boost, like GBM, XGBoost, combined with some logistic regression and decision trees. The highest rock AC we got was 0.62 and F1 score 0.09, which is extremely insufficient. So we started looking to other methods.
Yeah, because our overall performance wasn't very great. We tried enriching the data using crime data and other census data that was available online, but those didn't really help enrich our data after all. So we looked into manually flagging some of the existing features that we'll get into. And we also decided to break our model down into 5 smaller models by the item type to create a less imbalanced data set. In addition to our breaking down the model by jewelry type, we also did some manual flagging from EDA within each type of jewelry to try to engineer more predictive features to improve performance. So for example, if you have a ring, the source of business is web, the ring value is less than 4K, and the item count is greater than 1.5, we saw a dramatic increase in performance for that feature. And you can see on the slide, we have several other examples. And then it's important to note some key metrics for when we're looking at if a model is good performance. Just to go over a few, a ROC AUC, it measures the overall ability to distinguish between the majority and minority class. An F1 score, it balances precision and it also balances recall. And that's really important for us with unbalanced data. And then finally, looking at F2 score, twice as much weight is put with recall. So of all actual positives, how many are correctly identified, and compare that to precision.
So here's our final ensemble boosted tree that we decided to use. This relies on multiple different boosted models, 2 cat boost models and 1 XGBoost model. Each of these models are trained individually and fitted on the data using hyperparameter tuning with randomized search. And then after individually being fitted, they're then tuned on a weighted average and threshold-based classification. So each model carries a weight with it. These weights all add up to 1, so it's a standardized weightage system. And basically, we tuned on those weights and the threshold together on the cross-validation set to find the maximized performance, and then carried these thresholds, hyperparameters, and weights over to test on the held out test set. So here's our general performance on the segmented item data sets with the ensemble model. As you can see, there's increased overall performance across the board when compared to the original baseline model with just cat boost before segmentation and data engineering / flagging. And as you can see from the plot here, chain and pendant data sets saw the largest gains in overall performance. And although the ring ensemble model F scores remain low, the 0.13 increase in ROC AUC still indicates a strong performance improvement overall.
And for future directions, we plan to investigate fast sparse, implement for motive data, which JM has given us, and then experiment with alternative models and then maybe segmentation strategies. And then for last, we plan to convert all of our code from pandas into PySpark for parallelability and scalability.
Thank you.